Hi everyone. So today we are going to look at a new question, longest consecutive sequence. This is a lead code medium level question, and yeah, so I'm going to explain you my approach, and there is no limit for space. You can use as much space as you want, but there is a time constraint that we have to solve this question in big O of n time. Okay, so the question is as follows, that we have been given an unsorted array of integers num. We have to return the length of longest consecutive elements of any sequence. Okay, and we also have to solve this in big O of n time. So if you look at examples, so this is the first example. In this, the longest consecutive sequence is 1, 2, 3, and 4. Alright, so 1, 2, 3, and 4 is like longest consecutive numbers which appears in this array, and we have to return its length, so we have to only return 4. Looking at the second example, we have been given 0 to 8 numbers from 0 to 8. So and if you like see it and you rearrange it, or if you sort this array, you will be able to see that. And yeah, so its total length is 9. So we have to return that. And looking at the constraints, uh, the length of the array could be 10 to the power 5, but we have been given that we have to solve it in big O of n time. So it's not about solving, so it kind of like about if someone asks you this question in interview, so you should explain them in big O of n approach. Okay, but using this constraints, I think we can solve it in n log n as well, but we have been given that we have to solve it in big O of n time. And also the numbers could vary from 10 to the power minus 9 to positive 10 to, minus 10 to the power 9 to positive 10 to the power 9. And before solving question, like there are a few things that we should note. Okay, so how can we solve the question? So the thing is that, let's say I have encountered a number 2, and after some time I'm encountering a number 3. So I can see that I can like connect 2 and 3. This 2 can form a sequence. 2 can form a sequence with 3. Okay, so what I am saying is, let's say we have a sequence like this. We have an array like this. And array is like still going on, but we have found two sequences in this array. Two sequences in this array, and those sequences looks something like this. This is one sequence and this is one sequence, and let's say that this sequence is starting from 0 and ending at 5, and this sequence is starting from 12 and ending at 25. Okay, now going further down in the array, we found another sequence, and that sequence is starting from the number 6 and ending at a number, let's say 11. Okay, so ending at a number 11. So we are able to notice that this whole three sequences can form a single sequence. Okay, so main thing about this question is, using two sequence we can form a single sequence, right? So those two sequence can be this, or those two sequence can be this as well. So this is the main thing of this question. So using two sequence we have to form a single sequence. In this question, if we like divide our problem, first we have to like merge these two sequences. This is going to form a bigger sequence. Then we are left with two sequences. Then at the end we can merge these two sequences again. Okay, so like this is our question. Now when these two sequences, we already have these two sequences. When we encounter a new sequence, what we should notice that, is there a sequence which is ending a number which is 1 less than 6, a number which is ending 1 less than 6. So we can see that there is a sequence which is ending at a number 5. And also we will looking at, is there a sequence who is ending at a number 1 greater than 11. We only have to look at these two endpoints. Okay, these two endpoints. So that means that to look for a sequence which is ending at 5, I should store 5 somewhere, such that I will be able to access 5 very easily. Okay, and also I have to store 12 somewhere where I can access 12 very easily. Similarly, if let's say I have one sequence here as well, now I have to merge these two sequences. So if this sequence is ending at -1, then I have to look for 0. That means that I have to store 0 also somewhere where I can easily access the number 0. So this is it. But like, how can we store? How like we have to like store both of the endpoints of a sequence. So we also have to store 0 and we also have to store 5, and we should be able to access both of them in big O of 1 time. So listening to the time big O of 1, one thing comes to our mind, that is unordered map. So yes, we can definitely use an unordered map, and using that, let me explain you one test case as well. So we have been given a test case as, let's take this test case. So we have a test case like this. Okay, so what I am saying is, I previously said that we have to store a sequence and we have to store both of its endpoint. So what we can do is we can like make a map. So one map is going to like point from starting to end. So let me do that. Let me make two maps. So one map will point from starting index to ending index. Okay, or like starting sequence, the sequence like from which it is starting to from where it is ending. And another map could be like ending to starting. So what I am saying is, to like justify what I am saying is, let's say I have a sequence 1 to 3. So this map is going to store 1 to 3, and this map is going to store 3 to 1. Why this is necessary? Because let's say I encounter a number 4. Okay, I encounter number 4. I want to look at 3. I want to look at 3, like whether is there a sequence which is ending at a number 3. So for that I can directly look into this sequence. Okay, and let's say I found another number 0. For that I have to look for 1, and for that I can directly look into this sequence. Okay, so that's why we are making two maps, and like we will be able to search those respective values in the map in big O of 1 time. Okay, now let's just try to solve this question. So what this question means, so let's say we have encountered 1. So can we say that this is a single number 1? Can we say that we have found a sequence which is starting from 0 and which is also ending from 0, right? And then we will look for the number -1 and the number 1 in our respective maps. We won't be able to find them, so directly what we can do is we can store this 0 0 0 0. Okay, after this we encounter 3. Again we won't be able to find either 2 or 1, 2 or 4, 2 or 4, so we can just store 3 as well. Similarly for 7 as well, we won't be able to find 6 and 8. So in the maps, so we won't be able to find 6 and 8 in the map, so let's store 7 7 as well. 7 7 as well. Now we have encountered a number 2. So we will be looking for like a prefix sequence which is ending at a number 3. So we want a prefix sequence which is ending at a number 3. So how can we see it? So we would be looking at this map which is mapping from ending to starting. We can see that there is a sequence which is ending at a number 3. Okay, so what we can do is we can remove this from our map. We can store this value. So like this is prefix. So prefix, this is 3 3. So this is prefix start and this is prefix end. So we have done this, and this is also 2 2. This is given start and this is given end. So you can see that when we are seeing a prefix, our new series also, like when like we are removing this from 3 3 value from this map, we also have to remove that value from this map as well. That means that we have removed the sequence 3 3 from both of our maps. Now you can see that we have seen this sequence. This is sorry, I have done a mistake. This should be 3 3 here. Okay, so this should be suffix start and suffix end. Suffix start, suffix end. Yeah. So you can see that now the sequence is like 2, 3. So let's now also look for the value 1. So like any sequence which is ending at 1, but we cannot find that any sequence which is ending at 1. Okay. So what we can do is we can directly store 2, 3 here and 3, 2 here. And we have already removed the 3, 3 from both of these sequence. So this is like the current map values that we have till now. Then moving to the value 5, we want to look for a sequence which is starting at 6 and a sequence which is ending at 4. We cannot find sequence which is ending at 4 or either a sequence which is starting at 6. So we are just directly going to push 5, 5 and 5, 5. Now we encounter 8. So for 8 we are going to see a sequence which is starting from 9 and other sequence which could be ending at 7. So we cannot find a sequence which is starting from 9, but we can definitely see a sequence which is ending at the value 7, which is ending at a value 7. So we call for this. So this sequence is 7, 7. Also we delete it from here and we delete it from here as well. So like we know whenever like we see this value in the ending to starting map, we are also able to find its starting value as well. So using that we can delete it from this map as well. Okay, so we delete it from both of the maps. Now you can see that this is forming a sequence from 7 to 8. From 7 to 8, and this is also from 7 to 8. Going to the next number, which is 4. So we can look for the number 5, sequence which is starting at 5 and sequence which is ending at 3. So we can definitely see a sequence which is ending at 3. This is 2, 3. So we deduct it, so we remove 2, 3 from here. Also we remove 2, 3 from here as well. Now we see a sequence which is starting at 5. So we have made a sequence 2, 4 here. Okay, we have made a sequence 2, 4 here. Now what we have to do is we have to find its we have found prefix. Now we have to look for a suffix. So suffix is going to start at the value 5 and it might end anywhere. So we look at starting, right? So at starting we can see that there is a series which is starting from 5. So we add it here, and then this whole becomes a new series. We delete this 5, 5 from here. We delete this 5, 5 from here as well. We add our series 2 to 5 here and also a series 2 to 5 here. Now we encounter a number 6. So when we encounter the number 6, we are able to look, firstly we will look for the prefix. So prefix which is ending at a number 5. So we can see a series which is ending at a number 5. We remove it from here. We can see that this is starting from number 2. Then we also delete that from here as well. So this is a new series which is starting from 2 and ending at 6. So this is a new series which is starting from 2 ending at 6. Now we are looking for suffix. So for suffix we will look for 7. So a series which is starting from 7. We can see that there is a series which is starting from 7. We take this, we remove 7, 8 from here, we remove 7, 8 from here as well. This whole becomes a new series 2 to 8. This is mapped from 2 to 8. Right, similarly for 0 as well, when we encountered we have already encountered 0, but again we encountered 0. So now we can see that we have already seen 0 in our series, in both of our series. We won't be like mapping 0 again. We can look for the number 0 for like the suffix series, like a series which is starting from 0 or starting from 1, and a series which is like ending at -1. But if like at the end, like we won't be able to find -1 and 1, so at the end we won't be adding 0, 0 into our maps again, because that might cause a trouble. Alright, that might cause trouble. That's why we won't be adding 0, 0 again. Why is that? Because let's say now we encounter a number like 2. Okay, so 2, besides this 2, let's say it was 2 here, 2 present here. Okay, so if 2 was present here, then I'm looking at a series 2, 2, right? If I'm looking for another series, let's not say 2, let's say it is, okay, so what I'm saying, I'll like explain it to you later, but currently I forward it. Alright, so we won't be adding 0, 0, that's all we have to keep in mind. And now we encounter 1, For 1 there is a series which is ending at 0, so we will make it whole 0 1. And again there is a series which is, so we have to remove these values as well. Again there is a series which is starting from 2 and ending at 8, so we remove this as well, this as well. So this becomes a series which starts from 0 and at 8, starts from 0 and ends at 8. Okay, at the end, like, we have traversed our array, and if you look, and if we look through the map, and like find what are the numbers present in this, we will able to find that there are total number of 9 numbers present. Okay, so what I'm saying is, let's say at the end, in like this map, there are several values present like 10, 12, 15, 16. These are like the final answer after traversing the array. So we will be finding like the largest series. So this series has a length of 9, this series has a length of 3, this series has a length of 2. So we return the number 9 here. Okay. So let's just look at the code for this question. So let's look at the code now. So currently what I did was I have taken this array as input. So we have taken this array as input. Now we are going to solve it. So initially what we are supposed to do is we are supposed to make an ordered map, which will like point from integer to integer, and there are two kinds of map. So one map is S, which is pointing from so one map we have, there is S. So this map is pointing from the starting value of our sequence to the ending value of our sequence. And another unordered map we have is ending. So this is going to point in like the opposite direction. This is going to point it from like the ending to the starting. Okay. So wait, this is ending. Yeah. So we have done this, we have make two map. Now what we have to do is we have to traverse our array. So let's traverse our array, and in the array we are, let's say, at a value 3, so we are going to treat any value as a sequence. So we are going to treat it as a sequence like I comma I, like this is a sequence which is starting from I and which is ending at I as well. So we are going to treat it as this sequence. Now let's make that sequence as like starting and ending values. Now let's give the starting and ending value. So let's say int like given start equals to I, as well as given end equals to I. So we have given start and we have given end as well. So what we are going to do after having given start and given end, firstly we are going to look at the prefix. Okay, so how to look at the prefix? So let's say we have a prefix like this, and after that we have given start and given end. Okay, so we have prefix and we have given start and given end, and let's say the last value of prefix gets connected with the like the suffix, sorry, the given start and given end. So we can write prefix like this, prefix start, prefix end, and given start, given end. Prefix start, prefix end, and given start, given end. So we are going to look at a number which is so PE, if PE is equals to GS minus 1. That means that we can merge these two series, right? So because if like there is like a total of one difference in between them. So if P is, yeah, so this is it. So let's just look for that only. So let's store index auto x equals to so we are looking for this end value. Okay, we are looking for the end value. That's why we are going to use our unordered map for end, this map. So uh, e dot find given start minus 1, given start minus 1. So we are going to look for that, and if we are able to find the value, right? So there could be two cases that we don't have a prefix, and there is another case that we have a prefix. So we are going to differentiate it through this, like we are able to find this value or not. So if we are not able to find this, that then we are not going to perform the operations. So what we can write here is, if x is not equals to, so we are finding it in e, so e dot end. So this conditions means that like the x is somewhere in between the start and end. That means that the x pointer or the x iterator has found the value. And if the x iterator has reached till e dot end, that means that x iterator was not able to find that value. That's why it is at the end of our e map. Okay. So now that we have done this, we are going to like make two values. Prefix start equals to e dot second, sorry, e second, second, yeah, e second, and prefix and equals to e of first. So both of these values are int values, int and int as well. So we have made this, and sorry, this is not e, this is x, this is x. We have already found a value x. So like why the second value is the first, because like we are looking it and in an end map, right? So end map is pointing from ending to starting. So that means that its first value is going to give us, the ending value, and its second value is going to give us the starting value. So if we look so if you look here, you can see that first value is giving us the ending value of sequence, and second value is giving us the starting value of sequence. That's why we have done that. Now let's look at the code. So yeah, we have done this. Now what we can do is, after this we have to do few more things. Like we have to remove that value from both of the maps. So how can we do this? We can do this by saying that e dot erase, we are erasing value, and what value is erasing? So like we have to give the mapped value, right? So the mapped value or the first value. So in this we have to give pe, and when we are removing from s dot erase, we have to give the ps, the starting value. Okay, so using this we can erase the values in both of the maps. After this, we are able to see that like this is the whole sequence now, right? That means that GE is going to remain the same, given end is going to remain the same, but the given start is now going to change with the prefix start. So we can write that given start equals to prefix start. So by this we are able to find the prefix. Now if we look at the suffix, so GE and the suffix, so this can be also written as GE and suffix start and suffix end. So auto y equals to s dot find. So what value should we find in the starting index? We should find that GE plus 1. We should look for a value which is just greater than this ending value, right? So we are going to find GE plus 1. G is plus 1 value. Again, if we are able to find it, then only we are going to perform some operations. So that's why in this if statement, let's write if y not equals to s dot end, right? So again this means that we were able to find that value, and the iterator does not have not reached the end of our map. Okay, so we have done this, and after this what we are supposed to do is like we have to like pick two values, suffix start and suffix end. So we can do that by suffix start will be equals to y dot first, sorry, y first, and suffix end is going to be y second. We have done this. Again we should erase those values. So also these values are int, that's why it is giving us that error. And e dot erase, so ending dot erase suffix ending, and starting dot erase suffix starting. We have done this as well. Now you can see that given start remains the same, but the given end will now going to change with suffix end. So we can simply write here given end is equals to suffix end. Okay, given end is equals to suffix end, and after this what we are going to do is now we just have to directly map the given start with given end, and also in another map we have to map given end with given start. Okay, but before mapping we should look that whether there is like a duplicate value present or not. If let's say let's say I'm mapping 2 to 3, but 2 is already mapped to something else, then we don't have to map 2 to any value. Okay, so we have to look for this. So we have to write if statement like if let's say we are mapping given start to given end. Okay, so that means that we have to search that if s dot find given start. Okay, if like this is equals to s dot and end dot find given end if this is equals to e dot end. Okay, so both of the pointers are now going to end, right, going to the end of our map. That means that those values are not present in our map. Then only we are going to insert these values. So after like looking at this condition, what we are going to do is we are going to map them. So s of given start equals to given end, and end of given end equals to given start. We have done this. This is kind of it, but we have to like do one more thing. We have to iterate through the map to through every values. So after this for loop, let's make a int variable answer. Int answer equals to 0. Initially we have a sequence of size 0 of length 0. Then we are going to go through a loop for auto I in our map. So we can iterate through any map. So let's iterate through the starting map. Okay, so it will, what we want is we want answer to be get maximize. So answer equals to maximum of answer comma I dot second minus I dot first plus 1, and at the end we are just going to return that value. So let's just do it, and let's just copy this and let's just try to run it. So let's paste it and let's return answer at the end. So let's say return answer. So we are running for a test case. Let's see that if it gives any error or not. So currently we are not able to run. So after running it is giving us error. So error is because that we have not changed the value of nums to a. Okay, we have not changed the value of nums to a. So let's change that value. Okay, so it is getting accepted. Also, if we try to use this array as well, it should give us the same result. Let's try this as well. Right, so it is giving us the same result. Now let's just try to submit our code. Okay, so this our code is accepted, and yeah, this is it. So we have solved this question is in big O of n. We are only iterating through our array, and inside that array we are using unordered map. So unordered map usually takes big O of n time, but in the worst case unordered map might take some more time. That's why like they have given us 10 to the power 5 constraints at 10 to the power 5, because in the worst case it might become linear. The functionality of unordered map might becomes linear, but theoretically has been solved in big O of n. So we just have to give a theoretical answer. Alright, so this is it. And if you have any doubt, feel free to ask your doubts in the comments. So thank you.